I think now you can hear me, guys. Hello. I think now you can hear me, guys. Hello. Yeah, sorry for the delay, guys. I hope it's clear now. I think now you can hear me, guys. Hello. Yeah, sorry for the delay. Let me note it first. Sorry. I hope it's clear now. Okay. Sorry for the delay, guys. I think it's a 5 minutes delay. Uh, so here today we are. I think the schedule is also changed, guys. From now onwards, uh, I'll be taking on Wednesday as well as Saturday as well as Sunday, 3 days per week. Um, so on Wednesday we will start at 8 p.m. On Saturday and Sunday I will let you know. Most probably in the morning we can start. So in each session we will take up two algorithms, two puzzles or problems, whatever you call. The first problem we are going to look at is exponentiation problem. Uh, so given two integers x and y, we have to find x power y. We have to write a function such that it returns x power y. Leave the program part for now. Let's focus on the algorithm part. For example, if I give say 10 as x is equal to 10, y is equal to 5, the function should return me 10 power 5. 1, 2, 3, 4, 5. Okay. So usually for small values of x power y, I think small values of x and y, it can compute. So normally how the computer does, this will be multiplied in this way: 10 into 10 into 10 into 10 into 10. So 1, 2, 3, 4 multiplications, and we cannot compute 10 into 10 directly. Again, if you take it, it will be taken as this 8421 code. So in binary it will compute this and this, then you will get 8-bit integer 64 32 16 8421 code. So this is how it does. I will take another example. Uh, okay. Alright. So if you need say, if you need the application of this algorithm, usually what happens in network security, uh, here we can have a sender named Alice and a receiver named Bob. These can be any two names, guys. Suppose if Alice sends a message to Bob, uh, this needs some kind of a security here while sending a message. So what happens, this message will be encrypted. Okay, sorry for the bad handwriting, not very good artist. uh, and then at the receiver's end, Bob's end, it will be decrypted. So for this encryption and decryption, we use very complex algorithms. For example, after the class you can check this RSA algorithm. So what happens, it takes like we need to make high powers of x and y. this is modulus operator. So I think teaching this algorithm will be beyond the scope of this course. So I will stop here, but there are some applications where we use this exponentiation. Okay, so let's start with very basic algorithm. Maybe let me delete this brushes. Okay, so guys, let's say I'm taking powers of 2 to make our life easy. 16 power 8. So basic algorithm is 16 multiplied by 16 multiplied by 16, so on, 68 times. So it requires order of so if you are talking about x power y, it requires order of y computations, that is order of power multiplications. But we are looking at more efficient algorithm. Time complexity of the function should be order of log y. So we need some not linear one, we need logarithmic one. Okay, so now let's say this 16 power 8 I can split as 16 power 4 multiplied by 16 power 4. Yes, basic algebra. Now let's say this quantity is say m1 multiplicand, and this is also m1, correct? So if I whatever is this amount, I can just simply multiply with m1. I don't need to calculate 16 power 4 again. So what happens is, instead of doing 4 multiplications, I am doing only 1 multiplication. And there is no reason why we have to stop it here. Again we can do this as 16 square into 16 square, correct? And whatever is this 16 square, this is also the same thing. So I don't need to multiply 16 2 times and again multiply here. So I am decreasing 3 multiplications to 1 here. So, and again 16 I can do it as 16 into 16, correct? Now if let's say this is again 2 power 4, so initially here itself we can write it as 2 power 4 into 8 is 32. So we can write this as 2 power 32. So we can do it 2 into 2 into 2 into so on 32 times. So this is how we are doing, guys. So how many multiplications if you look at, if you take this as some kind of a tree, maybe it looks like a tree, the height of the tree will be equal to, so at every step for every multiplication this actually 16 is becoming 16 into 16 into 16. So what happens, initially there is a power of 8 at the base level, it is of y. Here it became y by 2, 2 into 2 4, so y by 2. So here it became y by 4, y by 8, and so on up to, it goes up to the point where there is only there is only a 1, correct? So the height of this tree is logarithmic y, log y to the base 2. So if you have y is equal to 8, I need 3 steps. Why? See here, 1, 2 and 3. Sorry. Are we taking any extra space, guys? It is an in place method, so we are not taking any extra space. Now we have taken a very simplistic case. Guys, let me check the chart once. I'm very sorry. I'm still doubtful why anyone is watching or not. Okay, I think no one is watching now, so you can go and watch the actual. You can go and watch the video after playing, so I can continue doing it. Okay, so this is simplest case. We have taken a very easy simplistic example. This is an even case. What if y is odd? For example, if I am looking at say 16 power 11 instead of 8. So in such a case, what we can do is I can write it as 16 power 5 multiplied by 16 multiplied by 16 power 5, correct? Now I can write this as 16 square into 16 into 16 square, correct? Now this is even, so no problem. So my algorithm goes like this. I am returning integer, say return integers power of x comma y. This is algorithm, guys. Don't look at the this is not any program or something. Power of xy. If y is even, return, what should be written as power of x comma y by 2 star power of x comma y by 2, right? Else if y is odd, then return power of x y by 2, okay, star x star power of x comma y by 2. If you think that this is evaluated again, you are wrong, guys. My compiler is smart enough to understand that this is the same function that we are computing, or otherwise you can simply first find this value and then plug it here, y into y, something like that. So that's it for this algorithm, guys. Let's look at the next puzzle. I think we can go to new puzzle. Okay, so this is the puzzle, guys. Given a linked list, check if the linked list has loop or not. Once we do that, we will have a supplementary question. Maybe that is more interesting than this. I will first explain the question. What does it mean? For example, this is my linked list. 1, 2, 3. Let's say I have this here. 4, 5, 6, 7, right? This is my loop. Again, after this is pointing to this node. Okay, so there is a loop, guys. Now first question is check if the linked list has a loop or not. So this is the question. So problem here is like if there is if we keep on going and we don't terminate, let's say we start from the root node or header, and we keep going, we never know what is the length of the linked list. It may or may not have the length as well. So if there is a finite small linked list, it will terminate. But if it does not terminate, that does not mean that there is no loop, or maybe we are yet to figure it out because maybe it's too big. We don't know. So we cannot keep going like that. So I will tell you the algorithm. I will take, let's say, 2 pointers. I am calling it as hare and tortoise. We all know that hare actually runs fast and tortoise actually moves very slow. So my algorithm goes like this. Hare for every iteration, my hare pointer actually jumps 2 steps. So from here it will directly go to this one. So it will take 2 jumps, 1, 2. And my tortoise, it is very slow, it can only move 1 step. So after n steps, okay, at n is equal to 1, or we can start with 0, n is equal to 0, hare and tortoise, this is the pointers. So let's say you can count 1, 2, 3, 4, these are the, let's say, serial number. So both are at 1. At iteration number 1, hare will go to 2, tortoise will be in, hare will go to 3, tortoise will be at 2. Here hare will go to 5, tortoise will go to 3. After third step, hare will go to 7. Okay, that means it is coming here. And tortoise will go to 4. And fourth step, so here if it moves 2 steps, it will take here as well as here. So it will move to 4. It will move to 4 and tortoise will move to 5. After fifth step, hare will move to 6 and tortoise will move to 6. So they will meet at this place. Okay, so when we find that hare and tortoise are pointing to the same list, that means if at any step hare is equal to tortoise, then report loop exists. If hare becomes null, okay, hare will become null first, so we don't need to check tortoise. Report, can we say that there is no loop? We don't know still, so we can't report anything. Sorry. For example, let's say I can erase, let's say for example, I am giving an example. here, let's say this is not there. This is, let's say, null. This is null, but I can have a loop like this. No, yeah, you can't have like this because it has only one link. If it is pointing to this, it can't go to null. Yes, so if at any step, if any step, if here becomes null, then report no loop, right? So what is the complexity of this algorithm? So this algorithm is given by a famous computer scientist, Floyd. Okay, fast pointer and slow pointer. Up to here is simple, guys. The interesting question is, let's say if I ask you, where does the cycle begin? I'm erasing this part as well. So this is the starting node where the cycle, if we start with here, this is where the actual cycle begins, correct? First of all, we have to prove that this method actually works. I didn't prove it yet that this will work. So what is the guarantee that this will actually work? We will just see now. So we will first take a parameter called relative distance. So if you look at this, what is the relative distance? Initially, the relative distance is the distance between hare and tortoise separated by the number of nodes. This is actually distance between hare and tortoise in number of nodes. Initially this is 0, guys. Now after step 1, this will become 1. After step 2, this becomes 2. After step 3, this becomes 3. So the gap keeps on increasing if there is no loop. Okay, let's say if there is a loop, after some finite period of time, after let's say S1 distance or S1 iterations we can call. Let's say this S1 is something I am calling it the non-loop area. So this is the S1. Okay, after S1 distance, both, so we can say iterations, both hare and or tortoise enters the cycle. Okay, this is my first part. Second part is, after entering cycle, relative distance will be covered in exactly C steps. So what is this C? If there is a distance between, if there are C nodes between hare and tortoise, so every time, let's say hare is behind, not behind actually, behind is not the right word because it's a cycle. So either it will cover in C steps or n minus C steps, where n is the total length of the cycle. So if we have n nodes in this cycle, at every step where the relative distance is getting decreased by 1. So after a finite number of steps, the relative distance gets to 0. Once it enters the loop, this becomes 0. So this algorithm will definitely work. Correct? Okay, let me see the chart. If anyone is following. I think there is no chat. Okay, maybe you guys can actually watch it at the end. Okay, now comes the interesting part. Let's say I want to report a node which starts. Okay. Let's say I'm interested in doing this node number 3. This is where the cycle begins. Okay, so I'm interested to know this part. So let me arrange this. Okay, so now I will give out some methods where we can find the starting point of the loop. So the method 1, let's say I will start with my head pointer at 1. Okay, now let's say they have met here. We know, we have seen it. So hare and tortoise are here. Let's say I keep incrementing my, I take another pointer x, which I increment. I keep incrementing till I reach this node, till I reach hare or a tortoise. Okay, then I will check actually whether I can actually reach the head. Okay, so if x equal to head, let's say head is equal to head plus 1. Every time I make head arrow next. So every time I am incrementing the head, and at some point of time, if I reach this case, then what does it mean, guys? This is also a part of the loop, correct? So if I don't reach, and if I reach, if x becomes hare or a tortoise, then what does it mean? This node, I'll change the color, this node which I am talking about, this is not part of the cycle, correct? Next I will come to this node, and I will keep incrementing till I reach hare or a tortoise. Then I keep incrementing. If I manage to reach this node before I reach the tortoise, then this is a part of the cycle. So if it does not reach, then I will go to the next node. Now see here, at this point I keep incrementing here, here. Now I reach this. That means this is the start of the cycle. So I will report this node. This algorithm works, guys, but the problem with this algorithm is it takes order. If s is the distance, if s1 or s whatever you call is the distance, and if my cycle length is c, so it is taking how many loops? C plus s, correct? Order c plus s. That means we can say that order, say s square, or order sc, whichever is least, correct? So this is not very efficient algorithm. A better algorithm can be, let's say if I can detect method 2, I will give you a clean method. You can find different methods, but it may confuse you, but I will give you a simple clean method. Detect cycle length C. Okay. How do we detect cycle length, guys? Our pointer here and tortoise are here. So I will stop the tortoise, or maybe tortoise, or I will stop the hare. So hare will sleep. You know the story. So I am making the hare sleep, and I am letting the tortoise move. Okay. So the number of steps taken by tortoise to reach the hare again will be my length of the cycle. This will be the length of the cycle. So what do we do with the length of the cycle? So what I will do is, I will again begin here, hare and tortoise. What I will do, I will take two tortoise, I will take another tortoise, T1, T2. I will take the second tortoise and run for C iterations. So after C iterations, it will reach somewhere, say here. Here the length is very small. So what happens, there is a distance of C here, correct? Now I will increment T1 and T2 by one step. T2 is equal to T2 arrow next. Guys, are you able to understand? I am running T2 by C steps so that once I enter the cycle, both will meet. So wherever both will meet first time, that will be the, so what happens, guys, like 1 2 3 4 5 5 is the cycle length here. So 1 2 3 4, so my T2 will start here when T1 is here. So if I move T1 here, T2 will be here. If I move T3 here, initially 1 2 3 4 5 6 7, 1 2 3 4, I think I should start here. So when T1 becomes this will become T1. Okay, so after certain number of steps, both will meet here. Okay, this is my method 2. So method 2 will take, I don't need to run each loop. So order of S is the length before the loop, and C is the cycle length. So order of S plus C is the time complexity. So this is very common question, guys. This is the question asked in very good companies like Amazon or something. So guys, I will stop here. Maybe on Saturday we can go through more lectures. Uh, Maybe I will go through the programming part of this. Uh, if you like this video, please hit the like button, and you can share the feedback in the comment section below. And also do share with your friends, guys. Let's have more subscribers so that, and please join the live chat, guys, because if you have any questions, I can answer in the live session. I can also record it and send you, but I want to make live videos so that it will be more interactive. Interactive sections are actually fun. So that's it for today. We'll join on Saturday. I'll inform the time. Thank you, guys. I'll stop streaming.